So what we have here is one of those sets for which there is no information. Now I've got one of these in storage, so it would be sensible to go and get that out of storage if I can find it and know which storage facility it's actually at. It's one of the things that has got overlooked. These are supposed to be a UK built set. Whether or not they're UK assembled or whether the whole thing is made here, I don't know. Let's just plug this into power. Run it up on 12 volts rather than 13, and there we go. So no received audio, and I've not got a mic with this. I don't know whether the mic has to run through the mic. What does it say on the top? Transmit no outgoing audio, no received audio, speaker wires unknown. So it would be useful to get ours out of storage, but that may not be possible immediately. So this may be part one, and this may be a 3.5 minute video. Still working on the EM27 with the wire bracket. There's some thoughts and there's a microscope going on to that. But I do have to do other sets, otherwise customers will end up an eternity. Right, so we can't put it into transmit unless it happens to be Cybernet standard. I don't know, it's not on my list. Well, that's giving me receive audio. It's also transmitting a tiny amount. So on low power it's doing 10 milliwatts, on high power it's doing 1 watt. Deviation. Wallow. See what we can hear. Get our talkie-walkie on the job. Testing 1, 2, no transmitted audio. So it's got no receive audio. Well, the fact we've got it up to the external aerial socket helps. So it's a fiberglass board, and it's a time when fiberglass boards certainly weren't going to be in CB radios. I think he said there was a coil missing, and there seems to be. But is it missing, or is it supposed to be? Got a preset to there. Right, so let's put, I'll put picture in picture on, and then we'll set the frequency counter. Out of interest, let's see what it's doing on transmit for, yeah, I mean it's 79089, it's like a frequency, that's neither here nor there. So we'll get our signal generator on, 2779125, and see whether it's receiving somewhere. I've got to find out, if it isn't, which of the IFs is letting it down. 79125, a bit further down, not that far down. 79125. I'm not going to tune it, so we'll actually have it on the right frequency. I'm not even showing you all this. I did press the button, but it didn't happen. So back to transmit, 2779090. I'll tell you what, let's bring it up to frequency. That'll do. Right, so signal generator 2779125. Signal. I've now got the signal generator on absolute full whack, and there of course is no signal coming through. Interestingly enough, squelch doesn't work. Why doesn't display high and low work? Somebody turn this into a novelty. Testing 1 2, testing 1 2, testing 1 2. So it would be useful to put into PA mode. It looks like it's stabbing that wire, doesn't it? There we go in PA. Testing 1 2, testing 1 2. Testing 1 2, testing 1 2. Right. I will just dig a Uniden mic out before we go much further. But nevertheless, we don't have any receive, so go back into receive mode. Where's the audio IC? Is it that little tiny thing down there? Could be. Yeah, I think it could be. Or is, oh no, it's this, isn't it? It's a TDA device. Let's go back to PA. Got the input there. Back to CB. Okay, so what we're going to do is plug our secondary signal generator in. And we'll see if either of the IFs are coming up. Oh yes, it's doing that one. Oh no, it's the yellow one I want. So that's fine. So we now need to look at 0.455. So with 0.44555, get rid of that one, put the blue one on. So that's working fine as well. So both the IFs are working. So the receive fault must be the actual front end of the receiver. Now that's interesting. Right, we'll put that down for now. So does this mean if I talk really close to this radio, because it's IF's work, it'll come through? Yeah, it is having some effect. It's like a rat's nest, isn't it, this? Not too long. I'll just cut the power. We've got two long wires here. I think if we can get the transmitted audio back, we've fixed it. I think there's a voltage rail going to be down. Without a circuit diagram, it's not easy, is it? The holes where there's missing components doesn't mean that there's missing components. That can be a red herring. I know they did a base station version of this. Not that I ever saw it, but I certainly saw a picture of a prototype. Alright, I'll have a look behind the scenes and see if there's something I can find. Right, a few hours later I find myself being able to spend some more time on this. So, we got to the conclusion there's no transmitted audio. The IFs were both working, so 10.695 and 455 kilohertz, but it's not receiving, and there's no transmitted audio, and there's no public address. Now, there's two common denominators there, aren't there? And there's no transmitted audio, there's no public address. So it seems that the microphone isn't actually going anywhere. So I have a quick look at the ICs. I'm guessing, without getting out data sheets, that pin 1 is the normal input voltage to the chip. So that's often the case. So pin 1 shows a voltage, pin 1 shows a voltage. So I've put my probe on the chip here, which is SL6270, which I know is what's known as a Vogad chip by Plessey. Very, very well thought after microchip. Vogad is a voice operated gain adjusting device, and it's one of the most desirable speech processor methods of all time. So I have just downloaded the data sheet, and in fact pin 3 is our power. So you see how barking up the wrong tree? Pin 3 is power. So let's see what we've got on pin 3. We have 8.7 volts. that sounds about right. It says supply voltage on the datasheet between 4.5 to 10. Absolute maximum is 12. That doesn't mean 13.8, that means 12. Looks like you can have 2 inputs and then it will do a sum of those 2 inputs. It might be something you do in noise cancelling when you have 2 microphone inserts out of phase with each other in one microphone. Right, so the next thing, it's time to poke my finger. Let's go into public address. I don't think we're going to find my set. It's not logged in on the computer, and without it being logged in, there's no location. So if it's not physically on a shelf, if it's in a box somewhere, if it's a storage facility somewhere, I have absolutely no idea. It's entirely my fault. It probably came, I probably bought it at a busy time. I know I bought it off a Radio Ham acquaintance, and he says, I've got this quite unusual CB. I paid £35 for mine, possibly incomplete and certainly not working. It's been converted to 10 meters, which is often the kiss of death to sets, and I don't know where it is. So what I have got is the photographs that he sent me of it, and that will help me. We know from my photographs where the speaker connects, which was one of the issues with this. So they're good photographs, and if I fix this and when I send it back, I'll make sure this is photographed in the greatest detail so that I can fix mine if I ever find it again. The trouble is there's 400 CBs here, or in storage. Did I say the word different? And did I say UK legal? Yes. Right, so where am I going to poke my fingers? I'll tell you what, we will poke my fingers on pin 8, main output. So ensuring I'm holding a screwdriver that's conductive, and at the volume's at full, I'll poke my finger on pin 8. And nothing happens. I'll poke my finger on what? Input 4 and then 7. Now then, we've got a hum. 1, 2, 3, 4, 5, 6, 7. So I was about preamp output. Have we got a preamp output? We have. It's on pin 2. Got some noise there. And main amp output is pin 8, which we didn't have anything on. So it seems that we've got audio going into this and possibly coming out. Otherwise we wouldn't be getting from pin 4. Supposing I found a capacitor off to the mic connection. think it's just decoupling. Right, we'll do some poking and prodding. Okay, we've got somewhere, but it's not going to help the no receive situation. We've got transmitted audio now, and there's actually, I'll just check this one. I've changed one capacitor, and I'll point out where. We'll just test this one. That was duff. It was open circuit, and the other two have read. The other one has read okay, and this is reading okay too. So they've just been part of the diagnosis. But one was faulty. I've changed 3, ground the VOGAD 1, 2, and 3, and this one turned out to be open circuit. Now, I'm prodding around with my finger like you'd expect me to, and I'm thinking, am I on the right microphone pin? Am I on the right microphone pin? And so on. Am I on the right microphone pin? And the answer is yes, because there's a second fault on the audio chain, open circuit feed through choke there. We'll nick something off something, it doesn't matter. That's the difference between a York 867 stroke Murphy DS602. They don't have these kind of things, so it lets the interference come in. But this doesn't, it's better planned. So now we've got transmitted audio. I've got that linked out. Testing 1 2, testing 1 2. Wallow. Bet there's some deviation now. Yeah, it's just gone off the scale. While it's greater than 25 kilohertz. So somebody knew which the deviation preset was, which is more than I do. It's that one, isn't it? One two one two one two 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1. Bizarre. If that is a deviation, well, it's either all or nothing. Anyway, we have got deviation, so we can forget about that. And if I switch to PA, testing 1 2, testing 1 2. Hello. Testing 1 2, testing 1 2 3, 1 2 3, testing 1 2, testing 1 2. 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. Yeah, well, I don't know what the farting is. Right, we'll get back to CB. We've got more noise there. Let's put the signal generator on. So we've got what I would not expect to be normal volume, but we have no receive. Again, we'll check with the hand portal. Testing 1 2. So we're going to have to look at power to the front end of the receiver, and I'll try to work out what they've done. So, one moment, we'll have a poke. Right, so I'll bring you up to where we are with this. So I didn't believe that the receiver isn't receiving. It may not be receiving on 27.79125, but I have now proved it is receiving. So by twiddling the VCO till it was out of lock, I was able to get the VCO to free freewheel, so to speak, at 27 megs, and was able to tune the receiver to about a 3 microvolt receive. So we know the receiver is actually working. I discussed with Mr. Chippie yesterday, and we were thinking along the lines that its phase-loop chip is not giving out the right thing on receive. I had a tune round, and there seems to be something on 24 megs and so on. So we're right. It isn't the phase-loop chip isn't generating the correct receive voltage. So I downloaded a data sheet. Here's one page, which is page 4 of about 21 pages. This is the MC145151P from Motorola, and quite a bit of experience on the slightly different version, the MC145152, used in the Tate 500 series of business radios. And I must say, I've only ever changed 2 in my life, and I'm not sure that this is faulty, but I wonder if we're going to be heading in this direction. But there's one test I can do to see whether it's at fault. Now these things contain 2,000, or is it 8,000? Yeah, I think it's 8,000 field effect transistors. So you need one of those to fail, don't you? And something's going to be awry. So it's quite clearly producing the correct frequencies on transmit, and I've checked channel 1, I've checked channel 40, and I've checked a few in between, and it's doing that. So you think, well, it can't be at fault, but it can, because what happens is when you go into transmit is it does its business. When you go into receive, pin 21 changes status, and the N code which is generated, this is the code between the channel selector switch and what goes to the data lines, is altered by, is it 820 something like that. So is this being told, we'll put that on one side, is this being told to go into receive from transmit? Now if it isn't being told to go to receive, can you see where we're getting? Yes. So I think we'll monitor pin 21, not Tango 21, that's me, pin 21. And we'll see what happens. There are parts missing in the transmitter. I may not be able to find my own set, but we have some really good photos here, and we can see that L10 is missing, which is wire wrapped around a ferrite bead, and we can see that L18 isn't as shown in the diagram. So I need to do something about L10. We can put 3, it looks like 3 lots of wire through a ferrite bead. And I'll tell you why I say this. We're getting about 3 watts out of the transmitter, but the harmonics are unacceptable. My test set's saying is actually put the danger light on. So at least we've got these photos to work from, and it also helps me if we ever do find our own set in the future, because I can see what's happened, and by photographing this one before sending it back working or not working, we don't know yet, do we? It's a difficult thing where to stop working on a CB radio. I mean, you can get these chips for 10 quid these days, but you know. Right, oh, we did check this 10.24 coming out with the oscilloscope and the ears, so that's all going right. So it is receiving okay. So pin 21, so how many pins have we got on the chip? There's pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, that is 21. 22, 23, 24, 25, that looks about right. So we've got 8 volts, so it's going to be logic high. And when we press transmit, still logic high. So the blurb says this input controls the offset adder to the data provided at the N inputs. This is normally used for offsetting the VCO frequency by an amount equal to the IF frequency of the transceiver. This offset is fixed at 856. When transmit is low and gives no offset, when transmit is high. So it gives a fixed offset of 856 when the TR pin is low and gives no offset when the TR is high. An internal pull-up resistor will ensure no connection will appear at logic 1, causing no offset addition. Well, it's not going into receive, is it? So I'm going to double check. We've got 28 pins. 28, 27, 26, 25, 24, 23, 22, 21, 28, 27, 26, 25, 24, 23, 22, 21. Still brings us to there. 14, 15, 16, 17, 18, 19, 14, 15, 16, 17, 18, 19, 20, 21. 8 volts in receive, 8 volts in transmit. I think that's where our problem is, folks. But how does it get that? So once again, what's happening on this side? 15, 16, 17, 18, 19, 20, 21. Hang on a minute, it has no connection. Oh, so that's why it's got an internal pull-up resistor and it's always in logic 1. I don't know how this, you see, this is the trouble, I don't know how this is working. If it doesn't have the offset, so how does the radio know when you're in transmit and you're in receive from the phase lock loop point of view? Oh, no connection. I can't see any logic ICs to make it do something different for receive. Well, looks like we're going to have to poke our head in it a bit further. So just poking around here, around the phase lock loop, there's a link here between diode 20 and 23. Because what I'm doing, I'm just checking none of these diodes are broken. Because they are glass, it can happen. And this wire link has actually fallen out at one end. And it won't go back. I'm putting a new wire link in because it's too short. Now it's possible that's not been soldered properly from new. It's also possible it makes no difference whatsoever. So I've just made a new higher quality link. Like that. I'll get that soldered in. So it was the end nearest the chip that looked soldered but wasn't. It's possible that it at one time it just touched by a capillary action, you know, that there we go. Power that back up. Well, it hasn't started receiving, has it? So there you go. Just goes to show. Right, well, I think we're going to have to leave this as a part 1 for this. Let's hope it moves on to a part 2. So we've put about 4 sessions into it over 2 days and come to the conclusion that it is receiving. But not on CB.